See, this India Cooling Action Plan is a comprehensive strategy launched in 2019. It has got a 20-year vision to provide sustainable cooling and thermal comfort while taking care of global warming and climate change. And we have none better than Mr. Jitendra Bhambure to introduce us to this topic. Mr. Bhambure is a senior member of the India Cooling Action Plan in the Refrigeration Technology Group. It is my pleasure to introduce Mr. Bhambure to all of you. Perhaps many of you, most of you know him, but it is my duty to introduce him for the purpose of this seminar. I have known Mr. Bhambure since 1995 when he was a planning engineer at Blue Star. By sheer merit and hard work, he rose to become the Executive Vice President of Blue Star for Research and Development. Though he was superannuated in 2018 when he achieved a certain age, Blue Star has not allowed him to go. He still continues to work for Blue Star in the capacity as an advisor on technology. He is the India representative in the UNEP panel for refrigerant. And as I mentioned earlier, he is a lead member of the India Cooling Action Plan in Refrigeration Technology Group. He is the founder president of ISHRAE Thane chapter and is very, very active in the technical committees of ISHRAE. Now, he has authored books on safety, corrosion, and COVID guidelines for ISHRAE. He is also an ISHRAE member. He is also the chair of the process division of the Institute of Mechanical Engineers, London. He is actively involved with policy forming bodies of the Government of India, Ministry of Environment, Ministry of Power, and also Bureau of Indian Standards. Over to Mr. Bhambure to tell us more on the India Cooling Action Plan. Thank you.
So thank you very much. And I would like to thank ISHRAE HQ to organize this seminar or webinar. And I'll try and share whatever information I have with me. I'll just start sharing my presentation. Is the presentation visible?
Visible, yes. Sir. Visible, sir.
Yes. Okay, thank you very much. So, thank you, Ram, for that nice introduction. And today we'll get into understanding of India Cooling Action Plan. But before getting into the India Cooling Action Plan, there is a lot of background which has happened for India to initiate formation of the India Cooling Action Plan. I would like to mention here that India was the first country to have such a comprehensive cooling action plan. Though US or Europe had something, but a comprehensive cooling plan, India was the first country. So a disclaimer here, which I have to give because I'm a Refrigerant Technology Options Committee on UNEP in the Ozone Secretary, that this presentation and the views here in the presentation are personal in nature and don't reflect anything on the RTOC, which is in the midst of publishing the next report for all 197 countries. Let us start with the trigger. CFCs, as we know, are the man-made chemicals were originally developed in 1930s, and they were already the initial chemicals were all what we know is CFC11 and CFC12, and they were adopted apart from many other uses. They were adopted in the air conditioning and refrigeration units because of their application. They were stable. They were cheap, they were non-toxic, and they were non-flammable. We all know the other refrigerants that were already existing at that time was ammonia, CO2, and hydrocarbons before the man-made chemicals came in. But we know all the issues related to safety, toxicity along with them. However, Frank Renaud, an American Nobel laureate and professor in chemistry, and Mario Milano, a Mexican chemist, together developed a CFC and ozone depletion theory, which they published as a research paper. So like all the things, the scientists do their research and publish a research paper of what is happening in the world and what is happening in the environment or in general impacts, and that triggers triggers the future actions. The Montreal Protocol is a global agreement of controlled substances that deplete ozone. So, what was the trigger? The trigger was that established that there is a relation between the chemicals, which is CFCs, and the ozone layer. The ozone layer itself is in the topmost area of the atmosphere, and when these chemicals reach at that point, at that place, they interact with the ozone. It becomes a chain reaction, because of which the ozone, which acts as a filter, it gets depleted, and because of which harmful UV rays start reaching the surface of the Earth. Now, this landmark agreement was signed in 1987 and entered into force in 1989. All the 197 countries, parties, the countries parties, are signatory to this protocol, and it became the first international treaty with complete ratification. So it is a remarkable achievement. Now, very important, the fundamental principle is common but differentiated responsibility. And why common but differentiated responsibility? Because everybody agrees that we have to tackle the environmental effects of the CFCs. However, the CFCs were used in large quantities in the developed nations. And while the developing nation, which they call it as Article 5 countries, participated, they were given certain concessions. How it was these concessions were decided. So the countries were decided into two groups. One was called as the Article 5 countries, and one is called as a non-Article 5 country. And the calculation method or the criteria that was decided is per capita consumption of refrigerant less than 0.3 kilograms, which means that the consumption is less. In turn, it means that the countries are in the category of developing economies or developing countries. This criteria became with this criteria they became eligible to be a part of Article 5 countries. Now, what happens due to that? Article 5 countries are allowed to delay the implementation of control provisions and are eligible to receive assistance under the multilateral fund. Multilateral fund itself is created by the developing countries, the rich countries, you can say. And these multilateral fund is available to the Article 5 countries for adopting new technology and changing over to the non-ozone depleting substances. Montreal Protocol has successfully curbed 98% of production of chlorofluorocarbons and other ozone depleting substances and significantly contributed to repair of the ozone hole. What happened this is as an alternative to CFCs or HFCs, which means that hydrofluorocarbons, there is no chlorine atom in this hydrofluorocarbon, were adopted. However, though it has no harmful effect on ozone layer in terms of depletion, they have got high global warming potential, and that became a cause of concern. So here is a pictorial diagram of what happens. We all know we get all the energy from the sun, and this energy comes to the earth during the daytime, but during the night time, the energy gets dissipated outside, and the equilibrium of both these things is the steady state temperature of the Earth's surface. Now, what has happened due to the greenhouse gases? Greenhouse gases are those gases which have got higher global warming potential. Some of the infrared energy, which is a heat energy, gets reflected back. It is seen here. You can see in a dark orange color, and because of it, it is scientifically understood that the temperature of Earth is increasing to pre-industrial era. Why pre-industrial era? Because post-industrial era, the interventions from humans started happening, because of which the delicate balance of the Earth got disturbed. And when did so this is only about 175 years old. Roughly, it is said that 1850s where the Industrial Revolution started. Now, we should understand the chemicals here. We have got CFC, HCFC, HFC, and HC. So what it is a carbon atom at the center, and which is connected to hydrogen, fluorine, and chlorine. Hydrogen is flammable. Fluorine adds to high GWP. Chlorine impacts ozone. So what is there? If, as I explained in the earlier slide, HFCs is all the three molecules around chlorine are there. Now with non-azoting, it's only HFC, not HCFCs, but HFCs, wherein it is fluorine and hydrogen. Now, if we have to remove the fluorine also, because it has got high global warming potential, then we are there only with HC. HC is nothing but hydrocarbons, and it becomes a flammable chemical compound. Now, this was Montreal Protocol. Montreal Protocol was adopted. As we said, it was most successful. It ensured that the ozone depletion has been addressed. Then came Paris COP21 in 2015. In Paris, it was agreed by the parties that the steps will be taken to restrict the increase in temperature to maximum 2 degrees centigrade before the pre-industrial level, and aim to or target to not allow to exceed 1.5 degrees centigrade. These were the two important aspects. Now we may discuss here Paris Agreement. There are many other global warming potentials, like carbon dioxide is there, methane is there. Methane, just to share with you, the largest production of methane gets generated from the landfills and through the animal farming, basically the beef farming. And methane has got its own this thing. But what is important is, if carbon dioxide GWP is 1, the GWP of man-made chemicals are much higher. And studies showed that if we are able to control the production and consumption of HFCs, then out of that 2 degrees centigrade, 0.5 degrees centigrade can be mitigated. And that's why the focus came on the refrigerants. Now, then what happened is, it was also understood and agreed that the framework of well-oiled machinery of Montreal Protocol can be used, is available as a vehicle, and can be used for addressing the global warming. With this background, the landmark agreement was signed on 16th October 2016, which is known as the Kigali Amendment to the Montreal Protocol. This is what is the scientists which showed that if business as usual is the red one, if we use the Kigali Amendment in 2016, then the blue line comes in. So we will address the global warming because of the refrigerants. Now, what is Kigali Amendment? The principle of common but differentiated responsibility continued. That means Article 5 countries and non-article countries will take their respective responsibilities. Very important that life cycle impact was to be considered. And why this came in? Because the new refrigerants, if they get developed, and if they have got a lower energy efficiency if they end up in lower energy efficiency, during the total life cycle, the indirect emissions will be high. And why it is? Because electricity, about 60 to 65% of electricity is still produced using fossil fuel. So carbon dioxide will get generated. Some amount of methane will also get generated. Considering the third point, important, considering that alternative low GWP refrigerants are not available for all the applications and all the product lines, unlike HCFCs or CFCs, there is a phase down approach adopted and not phase out approach adopted. As different, now the second point came in, like as different refrigerants have different GWPs, a system of CO2 equivalent was considered to arrive at the phase down level. Otherwise, each country will use different refrigerant. So how do we know that it has phased down to a certain level? Article 5 countries here too again were subdivided into two groups, and the group 2, where India is part of it, is in the high ambient countries group. Group 2 phase down timelines are they start from 2032, the first phase down, and it ends in 2047. But the freeze line or the reference level is 2028, and the freeze line itself is average consumption of each country of 2024, 25, 26 plus a baseline of HCFCs also. This is what is a pictorial representation of what will happen. Article 5 countries, India is the blue line. Article 5 group 1 is the green line, and we can say non-Article 5 countries like US, Canada, including Uzbekistan, Kazakhstan, are in blue, dark blue, and orange line. So you can see here, India negotiated well. 32, there is 10% reduction. Then again in 37, it is a 10% reduction, and the large, huge reduction is coming in 47, which is approximately, like 50% last reduction will come in 2047. And why this was done and negotiated well? Because by this time, patents of most of the refrigerants will get open. So India will not face any issue of using patented refrigerants, because the patents are not only for the refrigerant manufacturing, but they are also for the application of the refrigerants. Now, this is something which I can say as a summary of global climate change initiatives, of the Sustainable Development Goals. By 2030, India has decided to go net zero by 2070. Paris agreements under UNFCCC, as we said, 2 degrees. That is the second goal. And Kigali Amendment to the Montreal Protocol, reduce manufacturing and use of SFC 80 to 85% by 2004. I'm sorry, it is 2047, to ensure that the new technologies are energy efficient. Now, this is what happened. But what is India's perspective? India played a very flexible and comprehensive role in the whole negotiation process. Agreed to a lenient schedule as it consumes only 3% of the HFCs as compared to other countries like USA 37% and China 25%. Now we know that China is in Article 5 countries, Group 1, but today's consumption is very high of China. It is the second largest consumer of refrigerants. Though India has adhered to this agreement along with the Paris Pact, there are challenges, and because of India is taking up a Make in India project across all the manufacturing sector. Considering that India has got a hot climatic condition and there are requirements that are coming up as a growing demand, not only of air conditioners, it is for refrigerators, cars, and most important, the growing middle class incomes while implementing this total program. Now, implications on India, there'll be financial implication. Huge investments will be required in R&D. I can roughly share with you that each table change that happens of Bureau of Energy Efficiency, BE star labeling program in the room air conditioning industry spends end to end, training, labs, development put together somewhere about 300 to 400 crore rupees. So where are the investments will go in R&D? We'll have to buy technology and we'll have to get in technology transfer agreement. We may have to use patented technologies, and of course, manufacturing and service is also very, very important. Technological implications, availability of technology, time required for homegrown technology, and whether we'll not have competitive advantage as compared to the developed nations. However, on a positive side, this will incentivize business and scientific fraternity to invest in the financial and intellectual sources and finding more economic and environment-friendly technologies as alternative specific to India. We know that India is predominantly a cooling requirement, unlike the northern hemisphere, up north hemisphere, above the tropics countries, where heating is also very, very important. This I explained to you, like if you take CO2 equivalent, 404, which is 3922 as GWP, which means it is 392.2 tons of CO2 equivalent for a 100 kg of 404A. So you can imagine how much is the impact. I did a very small study that if a 1 kg of R410A leaks in the atmosphere, which has got 2100 as GWP is equal to roughly 2100 kg of CO2 get, you will require anywhere between 100 to 120 fully grown trees to absorb that much of CO2 equivalent refrigerant or CO2. So you can imagine how potent these refrigerants are. Of course, 404 is the most potent. The minimum is R32, which is 672, 134A around 1400, and 410A, which is 2100. This is what has happened. We have gone full circle. 1834, when refrigeration was invented, natural refrigerants were used. Then we went to CFCs, discovered that ozone depletion is a problem, went to HCFCs because HCFCs had still lower ozone depleting potential. From there, we went into HFCs, and now we are getting back to naturals and HFOs. HFOs, I'll speak whatever the issue challenges there with HFOs in the coming slides. Now here is a chart which was done by TEEP. TEEP is Technology and Economic Assessment Panel formed by Ozone Secretariat, and they do reports and as demanded by all the 197 countries in what they call as meeting of parties. So they had created this report, and they if we have to cut down phase down and reach 80 or 85% of the present levels of each of these countries, then the average GWP will come somewhere between 200 and 300 if we have to achieve this target. While today, other than hydrocarbons and few others, we don't have as such a solution. The minimum GWP used in India is R32 675, and then there are refrigerants which are higher than GWP, including if you take as US also, they are adopted 454B, which is 465 GWP. Of course, Europe is working to shift to natural refrigerants, more emphasis on CO2 and hydrocarbon. Hydrocarbon R290 is just 3 GWP. CO2 we know it is 1. Now, after the 2016 Kigali Amendment was signed, Kigali is capital of okay, in a Rwanda, I think, to best of my knowledge. And I was there when this agreement was signed. Where on the way back itself, Minister of Environment and Forest, the secretary, not secretary, the additional secretary and joint secretary, they decided that when we go back, we should do something. And immediately after coming back, they started working on the India Cooling Action Plan. It took some about 2.5 years. And in March 2019, this action plan was published. The name itself saying it is an action plan. It is not a report. It is not a plan. Why it meant so? Because it directs many of the government ministries as well as the other semi-autonomous bodies to take actions. And it is first of its kind, what I say, not only from the initiative taken, but how how they integrated the entire government, various government ministries. So a synergetic approach was taken, and other thematic groups, they covered everything. Space cooling in buildings, which we know all of us in ISHRAE, which is very similar to green buildings. Cold chain and refrigeration they took because the demand for refrigeration, cold chain for food security is going to transport air conditioners, be it buses, be it railways, and the passenger vehicles. Service sector, most important. And then indigenous production of refrigerants. Today there are refrigerants which are basically they are manufactured, but they were not necessarily invented by us. And we need to have a good manufacturing base. So indigenous production of refrigerants is one. Research and development. Research and development will come not only in refrigerants, but not only in the products, but also in the refrigerant. And then the complete implementation framework. So it is very comprehensive, as you can see here, covering everything. They also decided the goals. As I told that it is an action plan. So promote low energy consuming technologies, reduce cooling load, increase equipment efficiency, certified service technicians, harmonize policies of the government, create an ecosystem for R&D and innovation. These were the goals, and they're quantified also. What is a reduction in cooling demand by 20 to 25%. In HVAC, we call it as a heat load of a given area or a given building. Recognition cooling as a thrust area for research. This is important because we require cooling is a requirement. Cooling is not a luxury at all. We know it improves human efficiency. We know cooling is required for data centers. We know cooling will be required for precision manufacturing, including chip manufacturing, precision machining, and many. It is also required for tourism industry. So that is a thrust area has been decided. Then reduction in cooling energy requirement by 25 to 40%. We all know that star labeling program is there, starting with room AC. It is there in fans. It is there in ducted system. It is there in chillers. And we know the B is working both for VRF and ducted systems. Then important is reduction in refrigerant demand, because this is energy. Reduce the heating load, reduce the energy consumption, reduce the refrigerant demand also by 25 to 30%. So these together will reduce the impact on the global warming. However, to maintain many of the equipments which are already working in the field, we required good qualified technician. So they took government has taken the certification program for 100,000 service technicians, and they are completed. Now, the ICAP goal, we said it is 20 years perspective, but it is divided into three: short term by 2024, 23-24, medium term by 2029, and 2029, long term by 37-38. And then there are definite goals given for each of these short term, medium term, and actions also. I would highly recommend that you should download from the Ozone Secretary's website or MOFCC's website and go through in details. Now, this is the framework. There is government at the center, which has Ministry of Power, Road, Agriculture, Science and Technology, Housing, Skill Development, all the industry which get connected to HVAC industry and refrigeration. And then there were R&D institutes and think tanks like industry experts, think tanks and research entities like IIT was there, and there were research entities, policy research entities like CEW. And then there were industry associations and manufacturers. ISHRAE was on the board, Rama was on the board. I was representing industry on behalf of Rama. So you can see here that the framework was very, I would say, well organized and comprehensive. Then they said the departments and program initiatives. So what they didn't take only the department, they said instead of making new programs, it is better to use the existing programs that are already established by various ministries. For example, like you can say National Center for Cold Chain Development, doubling farmer income was the initiative. Or if you take state transport, public transport, then if you take the training, Pradhan Mantri Kaushalya Vikas Yojana, Ministry of Science and Technology, they got Mission Innovation. These programs in the lower half are already existing, and the India Cooling Action Plan was merged into all these initiatives. This is, you may have seen multiple times, but this is what you call as the temperature map or the climate zone map of India. The red one is hot and dry. The warm and humid is all coastal. Composite is entire, central India and North India, and the blue one, which is cold. And you can see here that parts of higher peaks of Sahyadri are cold. It is Bangalore, not Bangalore. I think it is Kurg. It is, I think, Mahabaleshwar, and then it will be Uti and maybe Kodaikanal. So this is there. I would like to mention here that when the subsequent slides come here, that about 60% of the population of India resides in hot and dry and the composite. What is composite? Composite is during summer the temperatures go high, and in the winter it goes low. At the same time, some parts of the month you have got a high humid climate also. That's what I said. It says here in the line number 3, which is about 55 to 95, while in hot and dry you can see that the humidity never exceeds 55%. Now, these regions are therefore the cooling requirements comes through refrigerant-based systems, non-refrigerant-based systems, and not in kind. Not in kind is something which are still not implemented commercially and is at an experimental stage. Non-refrigerant-based systems are fans and air coolers, and maybe some natural ventilation type. While refrigerant-based systems, I need not explain, all of us know. Just a minute, I'll take water. Able to hear me properly, no?
Yes, sir.
Hello?
Yes,
Yeah,
sir.
okay, thank you. Because I will not know otherwise what is happening. Okay. Now, how this action plan, as I said, like 17-18 was taken as a baseline, 22-23 as short term, medium term, term, and this was so cooling is mapped. Space cooling, you can see, is increasing as a in value terms also, as well as in terms of percentage within the whole thing. So you can see here that space cooling is very rapidly increasing. Cold chain, not so much, because it continues to be at a lower number. In 37, 38 also of the total thing, it was only 0.3%. 16% is coming from transport air conditioning, and refrigeration definitely is increasing. Then we see here the energy consumption that is coming, because if we recall, Kigali Agreement said energy is important. ICAP said energy consumption has also to be reduced. So you can say here that between 2017-18, 135 terawatt hours, it is increasing in 20 years to 585 terawatt hours. Now, this is business as usual. It is not with intervention. And we can see here that 52% in 37-38, the energy consumption will happen because of room air conditioner. Because in 17-18, the penetration of room air conditioner was somewhere around 6 to 7%. Now it is assumed that it is anywhere between 9 to 10%, and it will still grow. At least the penetration will become, per household penetration will reach 40-45%, which is like TV penetration, washing machine, and or refrigerators, domestic refrigerators. So you can see here what is happening. However, you will also see some interesting facts here, that fans, which is 30% of the pie, is reducing to 11% of the pie. And that is also because more and more people are likely to use air conditioners. Similarly, you can see that because the pie of due to air conditioning is increasing, both chillers is marginally increasing, VRF is increasing, but ducted system or packaged DX unit, it is reducing from 8% to 4%. Now, this is what will happen in those particular years. But from energy consumption perspective, the projections are have to be seen of what is likely stocks in the market which are operating. The assumption taken was the life of the air conditioner was taken as 10 years. That means they will get replaced every 10 years. And there will be new demand. And we worked out on two scenarios, like high growth and low growth. So roughly the starting in 2017, 39 million room air conditioners were operational. The calculations showed that. And with the growth, it will reach to, even in a low growth scenario, it will reach to somewhere 320, which is about approximately 8 times. And if you go in a high growth scenario, it will reach 15 times. My judgment is it will be somewhere in between the two. Of course, depends on many factors, because it's a 20 years perspective. But with the stability that we have, the growth engine that are there, it will be definitely higher than 8 times. Now, coming to the commercial floor requirement that is there, the commercial floor area is also going rapidly up. The green line shows the growth in commercial floor area, and the blue line shows what is likely air conditioned area that is there. We can see in commercial also it is high. Air conditioning demand in million metric ton. If you see the room AC, it was numbers, but here it is million metric tons, and that also is roughly going will increase by 6 times. So 8 times in room air conditioners and 6 times in commercial air conditioners. Now this chart shows what is going to be refrigerant based equipment stock that is going to be there. the room AC, chillers, VRF systems, and package air conditioner. And we see here that the pie. So it starts from 70 million and it goes 720 million, which means it is going to increase 10 times. But the pie of room air conditioner is more or less remaining constant, 81 to 88%. It is increasing, but you can say it is more or less remaining constant. Chillers is constant. However, the VRF system is going to increase. So you can imagine the amount of modeling that went into in creating the India Cooling Action Plan. Now, because energy was also a criteria, and as I said, fans are used in large numbers. Air coolers, which it has not got enough attention, but air coolers, what I'd read latest was that market is about some 40 to 50 lakhs, though most of it is in unorganized sector. That growth is also going to be very, very high. Fans as well as air coolers, you can see here millions of units. So, and now fans will reach about 1 billion numbers. Now this is refrigerant demand, and here we will have that the interventions have been worked out to achieve the targeted reduction that is there. So what is happening is this one is 2017. It is base. If the dark blue are the without intervention, but the light blues are with the intervention. What it means is that if we do the intervention, we can reduce the demand, and this gap is expected to be the target, which is 25 to 30%. Here is energy consumption again with intervention and without intervention, and here it is because it is energy consumption. It is considered with like air coolers, fans, packaged VRFs, chillers, and the room air conditioners. And here also the hatched verticals will be like just a minute. Okay, so these we can see that there is an working made on how much is reduction required and what is required to be done for that. That will come in subsequent slides. Just 1 minute. Huh? Able to hear me properly, no?
Yes, sir. Yes, sir.
Okay, thank you. So we saw energy consumption, energy reduction, the space cooling, like heat load reduction. As a result, though I had not shown a specific slide on that, but the heat load reduction, we all know ECBC. We know all that the green building initiative that has been taken, and there is ECBC-R also. And you must be aware that ISHRAE played a big role in creating the latest document related to ECBC also. So that will reduce the heat load. So heat load is taken care of, refrigerant reduction is taken care of, and energy consumption is taken care of. Now we come to the servicing sector. So deeper understanding of the RAC servicing sector has been mapped, and see we have to look at market growth. What will be the number of technicians that will be required? We have to take care of their livelihood, because air conditioning, specifically in the room air conditioning, is a seasonal business, and many of them get out of job moment May, June comes, or moment the monsoon comes. So how do we take care of the livelihood? How do we take care of emissions that are caused due to poor or due to inadequately trained technicians? More so, we'll get into few slides, is what we call as the life cycle management of refrigerant, or refrigerant recovery, recycling, and reclamation. Today, all of us know that, and this is not only India problem, I know it is a worldwide problem, that refrigerant is just left to air. And I have got my own thoughts on that, because unless and until we develop a circular economy, this recovery of refrigerants will be a hurricane task, because it doesn't make a commercial sense as of today. Then service practices, good service practices are very, very important. It is not service only, service practices includes installation practices also. Then training, if you have to have good servicing practices, if we have to meet the demand that is there due to market growth, we have to train more and more people. And whether we should look at the enterprise's characteristics, like the manufacturers, what they will do, or whether today most of the technicians are self-employed. So against that, whether you require entities coming very similar to urban CLAP. This is a study report, study findings. Like you can see that more than 50% of the technicians today are in informal sector, which has to come down. So they should come down to the aim in next 20 years to bring it down to somewhere about 25% of the total this thing. And the good part is that commercial air conditioners, a large technical sales force is informal. Same thing with MAC, but RAC, that is room air conditioners, the situation is not so good. Coming to refrigerant production, it was mapped again, and 24,000 or 24,300 metric ton refrigerant required, which includes service sector requirement also, will go up to 166,000 metric tons to 181,000 metric tons. You will be surprised that the study indicates that 40% of the total refrigerant that is consumed as of today is used by service sector, which goes against leak, which goes against breakdown is understandable, but leaks is the major requirement, and all these refrigerants with the present practices gets in the atmosphere. Now, what are the proposed pathways to reduce the demand? So first is reduce the demand. So how will you reduce the demand? You have to have heat exchangers which require per unit lower kg of refrigerant. So today, approximately 1 kg of refrigerant goes in a 1.5 ton, which is a normal size of a room air conditioner. So reduce the demand by going in for newer heat exchangers or efficient heat exchangers. Industry has done that in most of the cases, from 3/8-inch copper tube to 7 mm, and most of them are today 5 mm. Now, reduced demand also comes from the heat load. So it is expected that all the future buildings, when they absorb low, or when they have lower heat load, presently what we use 1.5 ton room AC, the percentage of 1 ton room ACs for doing the same job because of reduced heat load will go up, and that will significantly reduce the consumption of refrigerant. Alternatives we'll have to find for 410A and 404A. In room air conditioning, it is found, which is R32. But in case of high growth VRF systems, we still don't have. Similar with 404A. Luckily, in last 1 or 2 years, there are refrigerants which are found, which are 448, 449, or the latest ones, which is 454C and 455A. The last two which I told, these are they're A2L refrigerant, which is mildly flammable, and their GWP is less than 150. Many of the European manufacturers adopted them. adopt ultra-low GWPs like R290, R600. We know 600 and 290 are nearly 100% adopted in domestic refrigerators. In India, we have also adopted these refrigerants against 134A, which is 1400 GWP in deep freezers and smaller factory sealed refrigeration systems. Recovery, reuse, and reclaim, I spoke, and we'll have to find new blends wherein the research will come in. And how do we do this? So we have to come together. This is again still a gray area. We know that a long-term research has to be done by the institutes, because manufacturer produce products, institute produce technology, and these technology then gets adopted by the manufacturers to manufacture or develop products, because from the end consumer or end customer perspective, they appreciate technology, but as such technology has no meaning. Okay, Bluetooth technology has no meaning unless it is getting adopted in a product like I would say a phone. Similarly, a new refrigerant or a new heat exchanger or anything, theory has to get converted into products, and then the products will be used by the consumer. And similarly, it is not only for the refrigerant manufacturers, also have to come in play. So we have to have institutes, equipment manufacturers, and refrigerant production, private sector. They have to come together and try, it should be like a missionary action to achieve our target. Now I am coming to life cycle management of refrigerant and why it is critical. There will be huge quantum of refrigerant in the operating units even after meeting the requirements of Montreal Protocol, which is R22 system, Kigali Amendment, and also after the ICAP. That means even after the interventions, the units will be running in the field. And though theoretically we have said that room air conditioners' life is there for 10 years, in practice, many of these units will be used for 15 years or maybe 20 years also. And why the lives get extended? Because we know that domestic air conditioners are used for a limited period of time. They are used somewhere between, as we move from southernmost tip, where summer starts somewhere in March and summer starts in Delhi somewhere in mid-May or end May. So the use of air conditioner usually is somewhere about 4 months average. And that is why the life gets extended. While commercial equipments are designed for longer life. The study also has shown that even in the developed countries, the recovery rate at the end of life is negligible to a very limited thing. For example, the recovery of refrigerant in a very advanced countries like Japan is also 40%. In US, lower than that. In Europe, lower than that. So you can imagine how much of the refrigerant is getting released in the atmosphere. This will be the next big initiative across all the countries. And why I'm saying so? Because as a part of Refrigerant Technology Options Committee and TEEP Task Force member, we have created 2 reports on life cycle management of refrigerant. And these have been now under study by all the member countries, and they will initiate their action. From India perspective, the recovery and destruction of refrigerant in Gazette notification in 24. I exactly don't remember either 23 or 24 has been brought under e-waste rules. That means it is now regulated. So the countries are taking action and will be a big initiative. But as I was telling earlier, unless and until there is a circular economy and this refrigerant is, will be collected by technician. So unless the technician makes some money out of it, and there is a reverse supply chain, not a supply chain to supply the refrigerant, but reverse supply chain to collect the refrigerant and to either recycle and reuse or destruct it. If this doesn't get established, it will be very, very challenging. Now, now we saw in that cycle, which I saw, that the next generation refrigerants will be hydrocarbons, natural, and HFOs. But HFOs, why HFOs? Because HFOs disintegrate when released in atmosphere somewhere between 3 days to 7 days time. But that itself become a problem, because once they disintegrate, they will quickly mix in the soil wherever they get disintegrated, and from there the studies have shown that these refrigerants will get in the water cycle and then into a food chain, and that some of these constituents of the disintegrated refrigerants are carcinogenic as well as harmful to human body, as well as for both the animals also. With this study, 5 countries like Germany, Netherlands, Norway, Sweden, and Denmark have submitted a proposal to EU Commission and the Parliament, EU Parliament, and they are studying. But it is not only related to refrigerant, what they call as PFAS. These HFO has got PFAS chemicals. So PFAS popularly is known as what they call as forever chemicals. That means once they get into that, these chemicals are worse than the plastics. They will be there forever. Now, Europe, if they take an initiative and if they take an action, just banning 5 refrigerants under the new PFAS regulation will wipe out all the new blends that are there, be it 454B, be it any other newer refrigerant, including the HFOs. They will just get, because most of these new blends are blends of HFOs and the single molecule refrigerants that we are using, mostly R32 in most of the cases. So this is the real worry in our hand. So what is the status today? Because 5 years of ICAP has already happened. So there is uncertainty in adoption of HFO, which has got GWP less than 1. It was thought that it will be by this time we should have started using MAC. MAC is passenger vehicles and chillers, but it has not happened in a big way in both these product lines. Then room AC, which is largest consumption of refrigerant, is expected to go by 15% against 11 to 13% consumption as considered in ICAP, and lower GST is expected to boost this growth further. The growth of commercial HVAC sector is expanding and newer sectors are coming in. When this ICAP was made, the growth of AI or adoption of AI and the associated the computing systems that are required, or computers required, was not envisaged that time, but we know today that we require such systems, and the huge energy consumption is there. They require cooling. If India is to meet energy efficiency regulation, India to meet energy efficiency regulations under star labeling program, industry adopted R32, which got a GW plus 675 as early as 2018, and didn't adopt R410A in room air conditioner at all, which was having 2100. Now we know that the baseline of India will be average consumption of 24 to 26. Now, if we had continued with 410A, our baseline would have gone up and we could have adopted R32. But now with adoption of R32, this is going to be very, very critical, because next refrigerant, non-flammable refrigerant is not available. And with this growth, the service technician capacity building is not meeting the demand. Now, how it will impact on India? In the phase down process of HFC, MAC sector was expected to adopt HFOs and thus giving time for room air conditioning adoption, which is, we are not seeing any signs of that. HFOs continue to be a gray area for adoption. A high growth rate of room AC is likely to be a problem. And it is all likely that the 2028 freeze will face huge challenges before 2032, which is the first phase down. Managing energy in a efficient with alternate refrigerant is still not fully understood. That means we'll have to meet those requirements of energy efficiency. As I said, it is likely that we'll cross the freeze line by 2030, which was not envisaged during the ICAP development. We do not have alternatives. US has adopted 454B with 465, but it is not a long-term solution. As well, it is about 4 to 5 times costlier than R32. Training of technicians and meeting B star labeling program. These are all the challenges across all sectors. What I've done here, which is again, because 5 years have gone, that I have tried to capture to the best of my understanding what is required for all of us to do together. Not only I'm talking on the manufacturers, but the institutes like IITs or other institutes, other engineering colleges, as well as ISHRAE, RATA, and many other people. We need to immediately commence a study to understand the demand of refrigerant for comfort cooling. It was assumed something in about 5 to 6 years ago, but we should restudy after understanding the demand that is coming from MAC and evolving sectors like data centers. So new modeling we'll have to do. Adopt heat transfer technology will require lower per unit per TR refrigerant use in number of kgs. So we'll have to start that initiative. Advocate adoption of ECBC and ECBCR to reduce the levels reduce the heat load by all governing bodies. I don't think that all the states have still ratified ECBC. Okay. Capacity building of technicians, we have spoken and all of us know. And certification for the technicians is a very important and a must requirement. Midterm, invest in innovation, systems to lower refrigerant charge, risk mitigation for flammable refrigerant. Innovation is required. No, it looks like adoption of flammable refrigerant has become something inevitable. And we have to develop manufacturing technologies to make the systems leak-proof. Corrosion, all of you know that corrosion leads to leaks, so we have to work on it. But more so corrosion in microchannel heat exchanger, because microchannels are more efficient and they consume lower refrigerant. Develop India-specific standards for flammable refrigerant, for which we require India-specific study and data. Whenever I'm interacting with BIS, they said if you have to develop India-specific standards, we today don't have data for that or a research paper for that. Reduce leaks due to corrosion, which I spoke. Establish a circular economy for the refrigerant to reduce service demand of new refrigerant. It can be the recovered refrigerant can be used, which we spoke. Actions long term, which is 10-year plus perspective. I'm putting it here. District cooling demand for commercial and large residential complexes. Any big cities and new residential complexes. Why if there are, say, 10,000, 12,000 apartments, they will require some 20,000 to 30,000 room air conditioning. Why should we use room air conditioning? Why can't it be done by district cooling system? Because then you will have one central chiller which can be managed, both in terms of servicing, energy. It will be more energy efficient. So we have to look into it of a new ways of giving comfort cooling. Promote evaporative cooling. I said earlier that the 60% of the residents or the population of India is residing in hot and dry and composite climate. Evaporative cooling is a solution. However, we'll have to invest in innovation and R&D to reduce the water demand as well as for the humidity control. We have at a laboratory level, develop units which can avoid direct humidity built up in the conditioned area, and invest and involve institute in basic research which can be adopted by manufacturers in the products. Most important, to do all this, create an ecosystem for promoting robust and collaborative R&D. Manufacturers, equipment manufacturers, institutes, societies like ISHRAE, who are also doing research or helping do research, and the refrigerant manufacturers must come together. And I do know I've interacted with the Department of Science and Technology. They are ready to help. This is my last slide. We have got only one planet, which is blue planet. And on the right-hand side, we see the next generation from different countries. So I just want to say climate change is real. We have only one Earth. Earth has got 9.5 million species. Humans have a role to play to secure the future of the next generation. Thank you very much. And now I will stop sharing and we can, open for questions. So,
Bhambure,
yes, Ram.
Congratulations. Very, very insightful presentation.
Thank you very much.
But it is very alarming also simultaneously.
Yes, I know.
See, where I am sitting and watching this presentation, just about 200 meters from me, I am seeing a residential complex in 2nd Pokhran Road, 48 stories, 500 apartments.
Yes.
Like that, there are 6 buildings in that complex.
Yes.
I would like to ban room, window, VRF in the whole complex and install an ammonia chiller, water-cooled chiller in the complex. Takes care of 2 issues. One is your global warming. Second is your sewage disposal.
Yes.
Double benefit.
Yes.
So
Ram, just to add to this thing, when I'd worked through CEW and we had done a presentation of heat island effects of Greater Thane, and we have clearly seen that the Ghodbunder Road was warmer than what you call downtown Thane, and that is all because of the huge buildings that are coming up. Ram, just to add to this, there is a heat stack effect in these high-rise buildings, because of which the efficiency of the room air conditioner installed on the top floors is very low, and they also face a problem of recirculation of hot air because of the wind effect. So there are many things many advantage or disadvantage of using room air conditioner.
See, for example, you are not allowed to bring in a cooking gas cylinder.
Yes.
You are not allowed to bring in a cooking gas cylinder. Similarly, don't allow a room air conditioner to come in.
Yes.
Agree with me?
Today morning also we spoke, I was explaining it to Ashish Rakeja. I explained, see, there is CIA has formed a cool coalition where also I made a presentation, not this elaborate, but there also I strongly advocated for, what you call as the
district cooling should be pushed.
Yes, I agree. And I forgot to mention, when we had approached Thane Municipal Corporation, they told us that we are ready to give you treated sewage water that can be used for water-cooled chillers.
Bhambure, we don't need treated sewage water. Sewage is there in the complex.
That's the
Any
same.
any residential building produces more sewage than you need.
Yes, agreed. So who
Very
will
good.
take the other questions now? How should we go around?
You can take questions for 5 minutes.
Yes, please. So I don't
Also, there
know
are
who
many
will
questions
coordinate.
posted in the box.
Yes, I will. I was seeing at that. So I will try and answer those first and then try to go. So Amit Kumar Mittal, he is asked, what are the other contributors for ozone depletion and global warming? So I would say that ozone depletion is more or less addressed. So we need not worry about it. I said 98% is covered. But global warming is a big subject, and of course I've spoken refrigerants as such. However, I mentioned to you, if we stop the wastage of food, which gets which rots and creates methane, one. How do we manage our dumping yards? Second, entire world is eating beef, and when these cows, when they either through the flatulence or when they burp, they create huge amount as I said, management of food waste, management of agriculture. Food waste is not like, the waste that comes out from our house or restaurant. It is also the agriculture. We know that 30% of the food gets wasted, or the food produce gets wasted. Food is not a correct word. That all finally emits in form of either CO2 or methane. So these are the two. Then so Amit Kumar Mittal has got a lot of questions. So what extent ICAP has taken future development expansion into consideration, for example, multi-GW data center. So as I said, data centers was not on the horizon that time, and whether data center will come to such an extent. AI itself 7-8 years back was something like a lab thing. Sorry, 1 minute. Somdatta Banerjee, could you please elaborate on the point related to recovery, reuse, and reclaim? It is at the time of decommissioning of the air conditioner. It is time of when you shift your room air conditioner one place to other. It is at the time of repair of the air conditioner. Say a compressor breaks down at that time, or even if you have to, in large systems, if you have to replace the say coolers or replace the compressors, we can always pump down and use it. So that is what is at each of these stage we have to do a recovery. Reuse is reclaim is if it is to be treated, and there are standards. Like ISHRAE standards are there of the assessing the purity of the refrigeration. So it is reuse is the last, but first and foremost important thing is we have to collect the refrigerant. The next step, that is the first step. Okay. What models are available for district cooling for an existing campus like IIT campus? So Somatra Banerjee, I think this will be a roughly 26 kilo TR, 26,000 TR. Oh, IIT campus. I would put it this way, that district cooling is an established technology. The real challenge is a finance challenge here. It is not also a challenge of whether it is pays back. The first cost is high, and somebody has to, some policies will have to be made. Like Ramchandran said that they should not be allowed. should run some pilot projects. Some soft loan should be given. Something that type of work is well. Otherwise, from technology perspective, it is proven. Milind Joshi, what are the plans to have more trained technicians? Oh, this is a big question. Government, ISHRAE, Rotary, everybody is working on it. So, like more, the issue, there are 2-3 issues in this. One is, seasonal nature of the employment. One. Second is, there are more easier jobs available. So people are not getting attracted towards HVAC because this is a hard job. It is not like Swiggy. It is not like working as a driver or working as this thing. And the bigger problem is that they also don't get paid well. The payment is less. For example, the bigger, larger initiative, which are not spoken in my this thing, is we have, as an industry, we have promoted free installation of room air cases. Or even if the customer has to pay, he pays some 1,500 rupees. So 1,500 rupees is roughly 3% of the cost of the equipment. You go anywhere in the world, okay, and it is nearly 25 to 30% of the equipment cost that goes into installation and commissioning. So you can imagine what the technician will be earning. So it is all economics. It is all work that is there. It is all seasonality that is there. And that's why they're not getting attracted towards it. But efforts are being made. My other thought process is that the traditional way of bringing technicians to the room and teaching them is to an extent outdated. We don't go to government recognized driving schools to train ourselves. What we do, we get trained, we learn in our own way, but certification and that you are certified as a driver is done by the government. Okay. So something similar has to be done. Online training, something has to be done. We can create practical practice labs or practice workshop where they can come at any time and learn brazing or something of that type. What is then what? Amit Kumar Mopal. What are alternative domestic air conditioners? The alternatives are available. R32 we adopted as a medium GWP refrigerant ahead of curve, though we are not forced to do that by regulations. But the present alternative is 290, which is flammable, and there are challenges in that. There are issues related to service technicians, related to safety hazards, issues related to development of standards, and issues related to innovation, whereby the leaks will not happen. Any major work going on in developing technology process or material to trap, absorb refrigerant? Yes, it is there, but I am not gone in details to look at why can't we use ammonia-based chillers in standalone chiller plant. Again, promotion, the associated risk of toxicity and fear. Like we got fear of flammable refrigerant, there is a fear of ammonia. And I'm not studied, but I understand there are some restrictions to be used in residential areas because of the leakage issues. Okay, these are the questions. I hope I answered most of them.